Good evening from Brussels. I'm Jean-Louis Van Bella. I want to do a video. I have a few videos on various topics, management and mainly physics. This is a video on IT, on artificial intelligence in particular, which is a vast area. So I'll basically be talking about large language models. I should immediately acknowledge that, they often say my videos are not so professional with this notebook or this whiteboard that I use. So I inserted a picture and I will immediately acknowledge it. It's an AI photo generated on pixels available by Tara Winstead. Here, you can download it freely. It's quite beautiful. So no copyright issues here, Tara Winstead. Thank you for a wonderful image. At the same time, this image, as said, is beautiful. So I think a lot of people want to know what I call like what's under the hood. AI is a beautiful car, and we can drive it. And but yeah, the engine underneath. How does it work? Unfortunately, that's not a simple thing. I put here an image. Let me show that. Yeah, at the deepest level, we have bits and bytes and assembly languages, and then all kinds of programming languages, Python or C or other object-oriented languages or non-object-oriented languages. So let me make it smaller again. Oh, erase it. The gap between sort of what happens at the machine level and these wonderful chatbots that we have, that's huge. Let me say a few things about that to try to do what I want to do in this video. Yeah, you see it here, a car. That's also an AI generated image by the way, from stocktake.com. I take it immediately to also say, like, I'm gonna be talking about large language models. Image recognition works differently. There's many building blocks, I would say, that are the same for large language models and for image recognition. But the algorithms for image recognition, rastering, the input and all that is obviously different. But it's it's about objects. Recognizing objects, counting them. On top of that, LLMs will provide semantic meaning, semantic layers. I put a few concepts already there, but I'm gonna come back to them. So what's the objective? Basically, it's a bit to I put here this Max Tegmark. This is a video made by a good friend of mine, an old colleague, Vasily. He's retired now, and I would warmly recommend this video. It's 20 minutes, and it's basically quite a wonderful description comparing human and artificial intelligence based on, because there's some criticism, this is too high level, but based on a paper by Max Tegmark, which I'm gonna pull up if I have it somewhere here. Yes. Who is like a guru, I would say, in AI. He's been named by Times as one of the top 100 contributors to AI. Max Tegmark, you can Google him. So basically what he does in this article is it's a bit of a reverse engineering, I would say, of what goes on in a large language model. We sort of maps concepts and see how they work and how basically large language models store information. And he arrives at a number of concepts which I think are very useful, but at the same time probably may not answer your question, like how does it work exactly, not approximately, but exactly. To illustrate these models, I would say Max Tegmark, he distinguishes sort of like three conceptual levels, I would say: an atomic structure of meaning, a brain structure, and then sort of a galaxy structure. What's very nice is that he stresses that these are all very intricate geometrical patterns. He also develops the concepts of the concepts of semantic crystals, concept clouds, a few other concepts, all very nice, but Yeah, I would say like bridging the gap between this here. I'll pull up another resource. This is a very nice thesis by a psychology student, actually, Pablo Caceres, um, where he sort of digs into the history, which is quite long, of artificial intelligence, the first development of what was, well, the first artificial neuron, basically for pattern recognition, Macaulay Pitt's artificial neuron. Based on that, the perceptron, which, yeah, was a much more, well, it was basically an implementation, a machine implementation with an IBM computer and sensors and stuff, implementing that concept of an artificial neuron. More neurons were put into a network. That was the other line. And then sort of layers were added with or without feedback loops, and then you can go in what's currently convolutional networks, recurrent networks. That's sort of really interesting, but I gotta be honest, that takes it takes a while. To sort of see like, whoa, how does it work? And these are simplified representations of the different layers between input and output, the recognition of an object or of I would say a semantic atomic unit. So I want to do something in this video. It's only going to be 20 minutes, I swear, between this, I would say, more correct representation of how large language models, well, here it's also about image recognition, how these work without sort of the deep math. And as such, I'm going to go a little bit deeper than the video of my colleague Vasily Kritis. I'll go like one level deeper. So I would recommend you to watch this one if you want to have like a top level view in terms, or a top level understanding of what's what I write here, sort of what's under the hood. So how am I gonna go about it? I'm gonna talk about actually a conversation that I had with ChatGPT itself, because that's actually the main point I want to make. I made it back from the beginning. If you want to know how ChatGPT 4.0, the new generation, or O1 works, the simplest way is to directly talk to this chatbot. And what I find is that it's going to give you a level of an explanation at a level that is actually suitable to your technical understanding, and also sort of the basic points that you wanna explore. I'm going to talk a little bit about one thing that I'll pull up, and it's about abstract pattern recognition, I would say, in the context of a large language model. Let me see where I have the graph, because I will need it in a moment. Here, yeah. So, but before we go there, let me say the basic concept that you need is the concept of a token. What is a token? A token is an input. Can be it's a semantic atomic unit, I would say. It's a word or a subword, or maybe two words put together. And based on that, the large language model is gonna take input in. What it's gonna do is it's gonna vectorize it. It's gonna represent this input as an ordered set of coordinates. That's a vector, like 1, 2, 3 in the simplest thing. And in physics we have an x, y, z, 3 space coordinates and a time coordinate. So that's a vector. The vectors in a vector space in a large language model, while they're highly dimensional, they can have 100 or maybe 1,000, depends a bit on how much data they need to process. The more data they have, the more dimensions they can introduce. We will give a practical example of that actually, and that figure is going to make sense. Let's suppose that here we have this what is it, maybe about 40 objects that we feed into the large language model, and it's going to encode it. In the beginning, it's going to be what is called an initial random embedding. You can see here 2 dimensions, PCA dimensions. I will talk about that a little bit. Don't forget about the PCA, but think of it as a ranking of these objects that is in the beginning random, because we haven't taught the model how to, recognize or assign meaning to these objects. So they're all in black. But in reality, this is a space of, some, what you see next to it, of some fruits, some colors, some animals, some vehicles, so very different types of objects. And the learning will be that we will say, well, this is an apple, and this is an orange, and both are fruits. So based on the characteristics, the inputs that the large language model gets, it's going to start learning and ordering and grouping and changing actually the classification, or let's say the localization in this higher dimensional space, and learn how to distinguish between them. So in the beginning, as we see it, let me put that here, we will know what are fruits and what are colors and what are animals and what are vehicles. But for the large language model, it will all be what Hegel said, this is like the night in which all the cows are equally black. So then we start teaching the language model. They say like, hey, this is a banana, and that is, well, you have it. This is red, this is green, and both are colors. This is a dog, a cat, and both are animals. So after a series, and that's very important, the learning that this machine does, it will arrive at something that's probably maybe not perfect, but it will arrive at sort of an internal how would I call it, an internal clustering of properties, and these properties are purely mathematical. That will lead to it grouping the various objects into, well, these are fruits, and then these are colors, and these are animals, and these are vehicles, as shown by the colors here. So I won't go into the technical details. I said that the best thing to do is actually, pay. It's not expensive. A subscription to ChatGPT 4.0, and probably the free version of it will also give you, a ton of capabilities, I would say, and interrogate. And how does it happen? This probability distribution, this classification. You will see. I push it a bit for resolving an ambiguity. It gives me the precise mathematical techniques, I would say, how it does it. And but yeah, you can ask it all kinds of questions. Like you will find that a chatbot usually has a very pleasant conversational style and will react differently on your prompt. You can have an angry prompt, say like, "Give me this information, I need this." So how does it detect these kinds of nuances in your prompt? You can ask all these questions to it, and I would recommend that. Because as I said, I wanna not go above 20 minutes, and I'm at 13 minutes already. But these are the bridge, I would say, under this very high level conceptualization that Max Tegmark does, and what I'm trying to do here, if you understand these concept of tokens and how they are vectorized, of let's see here, what is this here? Yeah, of how these are embedded in a vector space, static or dynamically, static language models, natural language processing systems with static embeddings. Once an object had a meaning, it had a meaning. Dynamic embeddings will allow, shifting meanings and shifts into the coordinates of each unit. And then you need to understand there's several layers. I already showed this. A neural network. I don't know if it's in this one here. No, maybe these are feedback loops. Let me go to the convolutional neural network, several layers. Here we don't have feedback loops. The connections that are being made between these several layers, and that's a thing where we can say, like, we understand how they work, but the common criticism is that we do not understand how they work. Even the people who build them do not understand their work. I'm in the middle because it's true. The system, by learning from us, basically what is what, it builds these associations, simple associations or complex multidimensional associations between various vector objects, various vectors, and that's a very strange thing, how it creates meaning by indeed associating various vectors and in a very complex network of neurons and objects. This is something that I might have asked. You will say, like, well, what's the power? We have 85 billion neurons in our brain. How is it possible that a computer can have like 85 billion? That it can make so many connections. That's something also that you can ask and to ChatGPT-4. Where do I do it? Somewhere. Or maybe not. Yeah, no, I have in another chat. But you can ask. One thing is, large language models, they do consume an awful lot of computational resources, and they do take a lot of memory space. And I would say, as a rough estimation, is that large language models, they're quite specialized in what they do, not so specialized as our human brain, but their capacity is quite similar to our human brain, and they apply it to very specific fields of learning. And that's honestly where I think over the past few years, these large language models can be said to have become at least as smart as we are. Again, I won't be too long, but these associations, simple, complex, very important aspect if you're going to talk to ChatGPT about how do you work? What's the engine? How does it look like? Is serial and parallel processing. Large language models, we are also capable of parallel processing, and we're multitaskers in that and that. But the amount of parallel computing or processing, that's also a revolution in these neural networks that large language models do. That is amazing. I mentioned here a few other things like a principal component analysis, which are mathematical techniques that probably, if you go to them, it's not rocket science. It's like statistical analysis here. I can pull this one up. Applied to indeed, we have two dimensions here, but imagine vectors in maybe a very highly dimensional space with maybe 100-dimensional thousands, where you can not only cluster and see how close they are together. There are various distance concepts in Manhattan, or the classical Euclidean distance, or the cosine factor that you have in a vector cross product, or the sign in an ordinary dot product. But you can also associate in a principal component analysis sort of the main, the shape, I would say, of a cluster like that by associating, these black arrows, vectors that basically give like the thrust in one direction, and lesser thrust or spread in another direction. You can see this is sort of a long cloud. Max Tegmark's clock talks about these cluster-like or galaxy structure-like clusters. So PCI, these vector analysis, they capture that. So you can really say that large language models do have indeed sort of these, what is probably happening in our brain, this higher level synthesis of a lot of smaller elements and how they are structured or shaped in space. So that sounds all rather vague. I mentioned the distance concept. There are various ones. We explained this as a geometrical structure of meaning, of semantics. It's a lot more complicated than what I say, indeed, because various distance concepts will be there. There will be transformations of of variables or coordinates in this case, and yeah, a lot of stuff going on. So, what I would recommend if you really want to understand what how AI works is you don't need to be a programmer, or you don't need to understand the intricacies of yeah, how computers really work. But I would warmly recommend is that you do go through the effort of studying. Like this took me 2 3 days about a year ago to to go that through the history and the history of how it started, and then what is called the AI winter, what worked, what didn't work. There's been a lot of trial and error in building what we have now, these convolutional recurrent neural networks. And yeah, it is not rocket science, I would say. It is trial and error. But yes, what results from it is works amazingly well. And once you sort of go from this, I would say, not too technical understanding of what sort of the engine is composed of, then an explanation like my good friend gives here. How does it work? How does it mimic the human brain? What are the similarities? Also, what are the differences, of course? Then you are pretty well armed, I would say, to do what I really recommend to do, and it is to talk to ChatGPT if you want to understand and say like, well, how did you do this? How did you do that? I'm going to give one example that is interesting. You can always pull up how it does things by, for instance, this nice graph that it produced here. Or maybe, yeah, here it is. When it does stuff like that, you can say like, whoa, what's sort of the code behind? And usually, I mean, for a graph like that, it's Python now with its various graphing or mathematical components. It should pull up. Yeah. No, I don't see the component here. But PySci or other modules. And you can see really what it does to sort of explain what's behind. The other thing that you will see is that in ChatGPT, oops. By the way, yeah, if you want to read what I did here, I have a number of chats. Some of them I do make public. I have my private chats, my chats here on physics. I could never have done in the field of physics what I did without using a ChatGPT. Because that's maybe another thing if you wonder who I am. I publish on artificial neurons. It's sort of amateur research, AI and its impact on society. But my main topic is really fundamental physics, particle modeling, and from time to time, cybersecurity, the new threats. But that's who I am, and I use ChatGPT very very actively for all these things I do. And when you want to talk about discussion or sort of what is consciousness, what is self consciousness, I have a chat there. That one is not public, unlike the other one that I'm gonna show. You can find me on my LinkedIn page, Jean-Louis Van Belle, and the links are there to the chat, and so you can go through it, and then you can see, what do I want to know beyond this explanation or dialogue or discussion. I firmly believe in dialectics, asking questions to the large language model itself, getting its reply, and then focusing in, applying an attention mechanism. I would say LLMs have that yourself, and saying like, I want to zoom in on that aspect. Explain me exactly how it goes. And ChatGPT does that, and that's also one thing I wanna end my presentation with is there's a lot of fear of artificial intelligence, and it's because we don't understand how it works. It really is a tool, and tool in the technological sense of the word. And like any tool, tools are morally neutral. ChatGPT is not there to compete with human intelligence. But yeah, artificial intelligence, we're scared of it because you can use it for good and you can use it for bad. You can easily imagine indeed that chatbots, start being active or are programmed to be active to meddle on social media, sort of a botnet, I would say, on social media. Yes, that happens. Um, but is that a reason to sort of think that, whoa, artificial intelligence, danger? The evolution is going to happen anyway. Artificial intelligence, and that's very sad, is like any technology advancing quickly and rapidly and is being deployed on, unfortunately, defense, killer robots, battlefield drones, and that sort of gives it a bad reputation for the wrong reasons. So that's something I want to conclude with. I realized that my video, we are at 25 minutes and it has not been very professional, but maybe I'll redo it. I like to talk about these things, and they also inform probably a new paper that I will probably publish here on my research gate site on something that marks all my papers, something in between, the pure technical academic level, and then the informed reader, or the people who say like, I want to know how it works, but don't get too technical. So I try to find that middle ground, and I hope this video and me talking about it will help me to do a better video or a paper shortly on this topic. Let me see if I want to show that I didn't breach copyright. So this engine car is also, it's very wonderful what people put on the internet nowadays. Very creative. I have, what is this here? Yeah. Okay. Yeah. No, I'm done. And as said, Vasily, thank you very much. A beautiful video, much better and more professionally made, also with AI. Maybe you should teach me how to use AI to make more professional videos. I hope you don't think I've been rambling too much. If so, then probably you aren't listening to me anymore at this point in time. Anyway, so I wish you a wonderful evening, and please leave feedback at the bottom, or provide suggestions on what I could do better in this video. Thank you very much.